All right, so we're working on compound inequalities, and those are inequalities where it's multiple inequalities joined together. For example, 2x plus 5 is greater than 10, or 2x plus the square root of x minus 80,000 is greater than 1. For example. I don't know. I just made that up, obviously. Um, so you have multiple conditions, and you join them with or and. In this lesson, we're looking at the or type problems, um, and we're pretending that we've worked out these inequalities and got them down to a solution already. So the solution is x is less than or equal to 3, or x is greater than 9. So if it fulfills either one of these conditions, if it's something that's greater than 9, or if it's something that's less than or equal to 3, then it works as a solution to this compound inequality, right? So here's a way of writing out the solution. Here's two other ways of writing out the solution. This is set builder notation. X is a real number such that x is less than or equal to 3, or x is greater than 9. Here's interval notation. So the solution set is from actually this should be negative infinity. Um, anything from negative infinity up to 3, including 3. That's what this kind of bracket means, including 3. Or anything from 9, not including 9 because it's greater than 9, up to positive infinity. But this is all, I don't know, it just looks like a bunch of symbols, right? And in fact, it is just a bunch of symbols. So let's visualize it. Let's graph it. So how would you graph um, these solution sets? So let us draw ourselves a number line. No, it's not very good. Oh man, there we go. So we've got a number here, number line, I should say. Okay, so our key points here are 3 and 9. So I'm going to call that 3. And since 9 is greater than 3, I'm going to put 9 over here. Okay. So let's just graph them individually. X is less than or equal to 3. So it could be 3. Actually, let me do these guys in a different. Okay. X is less than or equal to 3. So 3 and anything below that counts. Or x is greater than 9. So 9 doesn't get included, but anything greater than 9. There. So there's the graph of the solution. So the solution set. So anything that's over here would be fine, or anything over here would be fine. So it's pretty inclusive, right? So basically any number except for the few numbers that are that are between 3 and 9. Of course, there's an infinite number of numbers between there, but uh, uh, anything except for this little range here would count as a solution for this compound inequality. All right, so let's actually start kind of back at the beginning and solve a compound inequality with that or, and then we'll graph the solution. All right, so you deal with them separately first. Actually, let's go blue. Okay, so 2x is greater than 10. So we'll just do each of these inequalities separately. Um, okay, so I need to isolate the variable. I need to get x by itself, so it's being multiplied by 2, so I'm going to divide both sides of the equation by 2. So I've got x is greater than 5, or um, so this looks like it'll take a couple steps to solve. So I want to get x by itself. So let's first get that 3 out of there. So we're moving it to the other side of the inequality. So by subtracting 3 from both sides. So we've got negative 7x is greater than, so negative 46 minus 3 is negative 49. And then I want to divide both sides by negative 7. So whenever I multiply or divide both sides of an inequality by a negative number, I need to remember to flip the direction of the inequality sign. So this will actually flip this way. So x is less than, um, so uh, negative 49 divided by negative 7 would just be 7. So my answer would be x is greater than 5 or x is less than 7. Now, but let me graph that. So let's plot our two key points here. We've got 5 and 7, so I'm going to call that 5, and then because 7 is greater than it, I'll put it right there. Yeah, so okay, so x is greater than 5. So we would not include 5, but anything greater than 5 would be cool. X is less than 7. Again, we're not including 7 because it has to be less. So x is less than 7 would go like that. So here's the graph of this. What you can tell from this is because they overlap, and because we're dealing with an OR type problem, meaning that a solution, a potential solution, could be either on this line or it could be on this line. Either way, it counts as a solution. Well, these lines overlap, so every real number is going to fulfill one of those two conditions. So we can look at this graph and say, well, actually, the solution is all real numbers. But you can graph it like that too. You could also, I mean, I believe you could just make it simpler by, well, forget that. The solution is all real numbers. Here's how to graph it, and yeah, yeah. So just graph each one individually, and then that's it.